Alright guys, we'll give a minute here for people to get logged in, signed up. Goal today is to go over the notes in the packet here a little bit so you guys can understand, and then help you guys out with the homework problems. The homework today and then the homework that will be on Tuesday, our next class, are roughly the same thing. Tuesday are the tougher problems, so I'll pop back up on live for a short video on Tuesday to help you out. But today we'll go through the Alright, hopefully you guys can see this here. Sorry, my video keeps pausing. Yeah, it's just the internet here at our house. Okay, so if I plug that in here, I'm just going to take a calculator out. Getting kind of lazy here. So 2 times 4 squared, I know that's 32, minus 1/3 times 4 cubed. Oh. So just plug that in. So we get 10.6 repeating. If I want to look fancy, math, enter, 32 over 3. So this exact area would be 32 over 3. Okay. So I'm going to show you we can do that same technique, but we don't always have to do that. Yeah, sorry about the video quality. I'll post this on YouTube. It seems to be better that way. But yeah, that's just my internet at my house. Okay, so we're going to go through this first problem here. If I wanted to find the shaded region underneath the graph 4 from 1 to 3, what we could do here is do the integral from 1 to 3 of 4 with respect to x. And so this is a long way of doing it, but it's not the, it's the long way, but not the wrong way. So what we can do here is integrate 4. 4 bumps up to 4x. And then we can plug in 3, we can plug in 1. So if I plug in 3, that'd be 4 times 3. And then I could subtract plugging in 1, 4 times 1. And so let's see, I'd get 12 minus 4, which is 8. So the area underneath this curve, which isn't much of a curve, it's a straight line, is 8. Well, this is the whole point. What we can always do is if we have a nice straight line, we could just use basic geometry. If we look, this is a 2 by 4 rectangle. 2 times 4 is 8 for the area. And so that's what we're going to look at today. It's like, how can we look at the function instead of doing the integral and all that work, use geometry. So like the next problem here, yes, we could set the problem up as an integral, or we could look this up and split up to like a rectangle and a triangle, or use a trapezoid. I'm just going to do a rectangle and a triangle. So if I look at this rectangle here, this rectangle goes over 3 and up 2. So that has an area of 6. And then this triangle goes over 3, up, let's see, 1, 2, 3. So what's 1/2 of 3 times 3? That's 4.5. And so add them together. Okay, that would have an area of 10.5. We could do the integral problem like we did, make this x squared over 2 and make this a 2x. Plug in 3, plug in 0, see what we get. We'd still get 10.5. Now the reason why this is nice is because we can have more complicated problems that we wouldn't know how to do the integral of. Like right now we don't know how to do the integral of the chain rule. Like if we got this 4 minus x squared inside of a square root. We don't know how to do the backwards chain rule. But if we look, this makes a perfect semicircle. Alright, so we know the area of a circle is pi r squared. We look here, this is the center, the radius is 2, so we can say this would be pi times 2 squared. So if this was a full circle, this would be 4 pi, but it's not, it's only half a circle, so we can divide that by 2. So the area of that one would be 2 pi. So if you can break the equation up into geometric shapes, it's a lot quicker and a lot easier to then find the area underneath the curve versus doing it the longer way. Now, this problem up here, this is not a normal geometric shape. Okay, that's a parabola. We don't have the area underneath the curve of a parabola, so we had to use this. And so what we'll find out later on as we go through this is, if you can use geometry, use geometry. If you can't, well then do it the long way. So I'm going to go through the homework problems. I'll try to do it on this here. This one's easy enough that I probably don't need to use Desmos to get the equations. But if you always want to do this a long way, you can. So first problem on the homework today is the integral from 0 to 3 of 4 dx. So what that looks like on a graph, 1, 2, 3, 4. So we have a straight line here at y equals 4, and 1, 2, 3. We can do more than that, but we're going to find the shaded region from 0, starting at 0, all the way to 3. There we go. Well, the one thing that's nice about this is once we graph it out, this is just a simple rectangle. The rectangle is 3 wide and it is 4 tall. So the area there, 3 times 4, is 12. So we have a basic linear equation. It's pretty easy. I'm going to just double check my answers as I go along, because I've been typing in the wrong answers for a while. Okay, no, that's 12. That's good. Okay, next problem, very, very similar. Get my eraser here. So we got the integral from -4 to 6 of 6 dx. So the integral from -4 to 6 of 6 with respect to x. Alright, so I'm going to graph this out. 1, 2. So you can see there I made a perfect rectangle. You really can't make a better rectangle than that. If we want to find the area, or this shaded region, since it's a nice perfect rectangle, we just count the base. Alright, so if we have x starts at 0, 0, and then it's an up 1 over 1 line. So I'm just going to plot some points here. We end up making a really nice triangle. So there's the equation. If we want to shade underneath the curve, oh, hold on a second. We're going to shade underneath this line from 0 to 4. So 0 starts right here in the corner. There's really nothing we shade, but then as we go over, we shade. There's 2, 3, 4. So we end up making a perfect triangle. Right triangle. This triangle has a base of 4 and then a height of 4, because if we think it'd go up 4 over 4, and a triangle is 1/2 base times height, so 1/2 of 4 times 4, 4 times 4 is 16, half of that is 8. Alright, we got one more question here, and then I will upload this video to YouTube. I apologize. Thank you guys for joining, but I'm sorry that it keeps pausing. Problem for today is, okay, what if we have the integral from 0 to 8 of x over 4 dx? Oh, can't see that. Alright, so if I was going to graph that, I'd probably change the height is 2. So it's 2 because if we go over 8, it goes up 2. If I plug 8 into this equation, that would be 2. So we're going to do 1/2 base times height. So that's 1/2 of 8 is the base. The height is 2. 16, half of 16 is 8 again. So the last two problems are 8. Sorry about the video pausing again, guys. I apologize. That's what it is. But I'll post this video on the Canvas page so you guys can watch it again. It should record fine there. And then that's it. So I hope you guys enjoy your weekend. And yeah, we'll see you on Tuesday because Monday will be meetings for all teachers. So we'll see you then. Best of luck. Take care. Stay safe. Bye.